Hello, everyone. I'm Dai from AWS. I'm excited to talk about best practice for Trino with Amazon S3. So let's get started. First, let me introduce myself. I'm Dai, a cloud support engineer at AWS. I'm responsible for solving most complex technical issues related to AWS Big Data services, such as Amazon Athena, AWS Glue, and Amazon EMR. And I'm also Athena subject matter expert, which is a certification in AWS support team. So I will start with the motivation for using Amazon S3 with Trino. Then based on how Trino interacts with Amazon S3, I'll discuss the common challenges in scaling Trino workloads. And finally, I will talk about the best practice for using the Amazon S3 with Trino. So let's start with the motivation for using Amazon S3 with Trino. Amazon S3 is a cloud-based object storage service that offers durability, availability, and scalability, security, and cost performance. This is a feature of Amazon S3, and let me explain the use case of Amazon S3 with Trino. Trino's ability to query data from data lakes offers a powerful solution for efficient data analytics. And Amazon S3 is the best place to build a data lake because Amazon S3 has a virtually unlimited scalability, cost performance, and supports a variety of security, compliance, and audit capabilities. Currently, more than 1 million data lakes run on AWS, so it's quite common to use Trino with Amazon S3 data lakes. Now you know Trino with Amazon S3 is a great combination for efficient data analytics, and many people are using it. So let's discuss some common challenges you may face when scaling Trino workloads. Today, I will talk about 4 common challenges in scaling Trino workloads: huge data scan, HTTP slowdown error, many small file issue, and unneeded data is stored. So now I will explain the details of each challenge based on this architecture. Let's say clients analyze data stored in Amazon S3 using Trino, and at the same time, other applications read data from Amazon S3. To access Amazon S3 from Trino, you can use Hive connector, Iceberg connector, Hoodie connector, or Delta Lake connector. And in this session, I will focus on Hive connector because it's mainly used for Trino to query Amazon S3. The first common challenge is huge data scan. You may need to handle huge data because data is growing rapidly in data lake. Scanning huge data leads to slower queries, out-of-memory errors, and high costs for S3 requests against your bucket and objects. So this is the first challenge. And the second challenge is HTTP slowdown error. This is a S3 error that occurs when S3 request rate exceeds threshold. So let me explain the performance characteristic of Amazon S3. Amazon S3 performance is defined per prefix in a bucket, not per bucket. So this is an example of prefix. You can achieve 3,500 put copy post delete request or 5,500 get head request per second per prefix in a bucket. So if your request exceeds the threshold, you will face the HTTP 503 slowdown error. This error occurs when multiple clients make concurrent requests to access data under the same prefix. So if you have application access data intensively, and you may receive this error. And it can be a bottleneck for your data lake, depending on your access pattern. So let's dive deeper into how S3 requests are handled in Trino. There are 2 parts, coordinator part and the worker part. So now focusing on the coordinator part. Let's say a client submit a query, and based on the query, the coordinator created query plan. After that, coordinator divides the plan into stages. And the stages are also broken up into tasks, and then the coordinator assigns tasks to workers. Then the coordinator begins to enumerate splits, which are descriptors for segments of underlying data. The splits are assigned to the tasks, and the worker processes the splits. When the coordinator is enumerating splits, the Hive connector is used to access Amazon S3. And the Hive coordinator asks Hive connector to enumerate splits. The Hive connector describes splits in the form of a path to a file with an offset and length that indicates which part of the file needs to be processed. So when enumerating splits, the Hive connector calls list request to Amazon S3. So if you read many files, the number of list requests to Amazon S3 is quite high because of enumerating splits. So now moving on to worker part. After the tasks are assigned, workers process the splits. Based on the information of splits, the worker calls get request to Amazon S3. If the SQL statement is insert or create table as select statement, put request called. As with the coordinator, if the worker reads more files, the number of get requests increase. Now we understand how S3 requests are handled in Trino. So if coordinator make many list requests or workers may make many get or put requests, the request rate exceeds threshold. Then you will face HTTP 503 slowdown error. That's the second challenge. The third challenge is there are many small file issues. Before I explain the small file issue, let me talk about the splits and how to calculate the number of splits, because splits are a key factor in understanding small file issue. Splits are processed by tasks assigned to workers, and splits are smallest unit of work assignment. So the number of splits is related to a parallelism of query. In terms of query performance, you need to consider how many splits are created. Roughly, the number of splits is estimated by these parameters. By changing these parameters, you can control initial size of splits, maximum size of splits, and the number of splits. So let me explain how to calculate the number of splits using example 1. Let's say there are 1,000 files to read, and each file size is 10 kilobytes. Until the number of Hive max initial split is reached, the number of splits per file is determined by Hive max initial split size. At this time, since each file size is smaller than Hive max initial split size, one file becomes one split. So in this case, 200 files become 200 splits. So when Hive max initial split is reached, Hive max split size is used instead of Hive max initial split size for each file. Since each file is smaller than Hive max split size, the remaining 800 files become 800 splits. So in this case, 1,000 file splits will be created. If there are 200 files and each file size is 10 kilobytes, it will be 2,000 splits. So in general, one file is one or more splits. And many small files read many splits. And you need to know if the number of splits increase. The number of the S3 requests also increase. Let me explain another example. There are 10 files to read, and each file size is 1,000 kilobytes. The total size of data is same as example 1 that I explained in previous slide. And since each file size is smaller than Hive max initial split size, one file becomes one split. So in this case, 10 files become 10 splits. So in total, total is 10 splits. Although the data size is same, but the number of splits is totally different. And this difference affects the query performance and the S3 requests. So let's get back to the small file issue. As mentioned in previous challenge, Hive connector calls list request to retrieve list of files to generate splits. And also worker reads data from Amazon S3 by calling get request. If there are many small files and the request rate is high. So many small files could lead HTTP slowdown error. Also, if there are many small files, coordinator enumerates many splits. Because each split is small, there are computational overhead, and it affects query performance. And last challenge is unneeded data is stored. With Amazon S3, you pay for the storage you use. So if data is growing, the storage cost increase. And also, you may scan irrelevant data, and then query performance is getting slower. And there are data with known or predictable access patterns, and data with unknown or changing access patterns. Additionally, you may have old data that is no longer relevant. In such case, you may need to manage your data lake in terms of cost optimization and security. So now you have seen 4 common challenges in scaling Trino workloads based on how Trino interacts with Amazon S3. I think some of you might have faced these challenges. Someone? OK, thank you. But don't worry. You can resolve these challenges by using best practice I covered. I will talk from now. So let's get started. So these are topics I will talk today. First, let me talk about optimizing data layout, partitioning, bucketing, and managing S3 prefix. Partitioning is a solution for huge data scan and HTTP slowdown error. Partition divides your table into parts and keeps the related data together based on column values. So by using partitioning, you can reduce the amount of data scanned per query. Without partitioning, if you query a table, Trino essentially reads all data under the S3 path of the table. So if you define the partition column when creating a table, you can restrict the amount of scanned data by using the partition column in where clause of the query. In this case, Trino only reads partitions where view date is equal to 2024 June 30th. So you can skip relevant data when querying the table. As well as partitioning, bucketing is the solution for the huge data scan and the HTTP slowdown error. Bucketing is a technique for distributing records into separate files based on the value of one or more columns. This ensures that all records with same value will be in the same file. So by organizing data this way, you can perform efficient filtering because only the relevant buckets need to be processed and reducing computational overhead. As an example, the table is bucketed into 50 buckets by the state column. And by running this select query, you can perform efficient filtering. And when you choose partition columns or columns to bucket them, you should consider based on the cardinality of data and the common query pattern. So next solution is managing S3 prefix. This solution mitigates HTTP slowdown error. Managing S3 prefix can help you achieve higher request rate on Amazon S3 because the performance rate on Amazon S3 is defined per prefix. Partitioning can help you to scale Trino workloads because you can avoid huge data scan and HTTP slowdown error. However, as a characteristic of data lake, date column is often chosen as a partition column. And data ingestion to latest data often occurs. So, and many people may read new data. As a result, there is a heavy access to a single S3 prefix. Then your request rate may exceed this threshold per second, and you may encounter the HTTP slowdown error. So let's think about how to overcome this error. Because S3 partitioning rate, S3 performance rate is defined per prefix, one solution is to add multiple prefix, S3 prefix, to scale S3 performance. You can extract some columns from data and include column names and value in the S3 prefix like this. By increasing a number of prefix, you can parallelize the read and write operations. And there are no limits to number of prefix in a bucket. In this Hive-style partition structure, you can have one prefix per country. And you can extract better S3 request performance when reading a table as a S3 scales out based on incoming requests using this prefix. So if we create 3 prefix in the S3 bucket to parallelize reads, you could scale your read performance to 16,500 read requests per second. This solution is really important for mitigating the HTTP slowdown error in Amazon S3. As an example, I use the country column to add S3 prefix. So you might wonder, which column from the data should we select when adding S3 prefix? In this case, it is good to choose columns that have multiple different values over recent records. It is also advisable to choose columns that are frequently used as predicates in your queries. On the other hand, if you choose a low cardinality column, you cannot expect performance improvement. So next topic is optimized data size. Optimized data size is the solution for many small files issue and the HTTP slowdown error. You can run the optimize command to merge small files into a larger file. So running this command, you can resolve many small file issues. Then you can reduce the number of S3 requests and GET requests. Here are the steps for the optimize command. If you run the optimize command against Hive external tables, for example, the table is registered in GRU data catalog. You need to set a Hive non-managed table write enable true in the configuration file for the Hive connector. The optimize command is disabled by default, so you need to enable this session property before running the optimize command. Then run the optimize command. If you set file size threshold parameter, all files in the table that are under 128 megabytes in size will be merged in this case. If you use Trino on Amazon Athena and the table is a Hive external table, you cannot run the optimize command as shown in the previous slide. So in that case, one solution is to migrate to Iceberg table. Because Iceberg has the other feature that manages small files, then by using this feature, you can run merge small files into a larger file. You can manage the many small file issues without building custom pipelines, such as running the optimize command. This is because you can use automatic compaction for Iceberg tables on the GRU data catalog, which merges small files into larger file. Of course, you can run the optimize command against Iceberg table in Amazon Athena. For the migration to Iceberg table in Athena, you can run the create table as select statement. Here is an example of the create table as select query. So next, I will talk about making well-designed retries. Making well-designed retries is the solution for HTTP slowdown error. To mitigate HTTP slowdown error, increase retry limit for Amazon S3 requests. Amazon S3 automatically scales in response to sustained new request rate. Then Amazon S3 is dynamically optimizing performance. So while Amazon S3 is internally optimizing for new request rate, you receive HTTP slowdown error responses temporarily until the optimization completes. So you can increase retry limit to take advantage of horizontal scaling capability in Amazon S3. Then your query can succeed eventually. In Trino, you can change the maximum number of retries. And there are two different parameters related to maximum number of retries. The parameter you need to change depends on how you access to Amazon S3. There are currently two ways to access to Amazon S3, native implementation or legacy version. In the case of native implementation, the Trino file system API is used. And in the case of legacy version, Hadoop API is used. So based on how you access to Amazon S3, you need to choose one parameter. So this is the case of Amazon EMR. By default, Trino uses EMRFS to access Amazon S3 in Amazon EMR. EMRFS stands for EMR file system. And by using this, you can read or write to Amazon S3 from Amazon EMR. In EMRFS, you can increase the number of retries by changing these parameters. So let's move on to taking advantage of Amazon S3 storage class for the challenge unneeded data is stored. Amazon S3 offers a range of storage class that you can choose from based on performance, data access, resiliency, and cost requirements on your workloads. And Amazon S3 storage class are purpose-built to provide lowest cost storage for different access patterns. So before choosing a storage class, you need to identify your access patterns. There are two kinds of access patterns, known or predictable access patterns, or unknown or changing access patterns. For example, you create daily report by using Trino, and the content is frequently accessed right after you upload it, but becomes infrequently accessed a few weeks or perhaps even a few days later. That's the data with known or predictable access pattern. On the other hand, at the time of saving data, you don't anticipate who and how it will be used. Perhaps the data will be accessed in a few days or few years later. That's the data with unknown or changing access patterns. I think you may have this kind of data in data lake. So let's talk about data with unknown or predictable access patterns, such as data that becomes infrequently accessed after a definitive period. If you have a use case with known access pattern, the next step is to choose a storage class that best matches your requirement and how you want to use your data. Let me explain some of storage class. In the case of S3 standard IA, the storage cost is cheaper than S3 standard. But the S3 request cost is higher. In that sense, standard IA is suitable for infrequently accessed data. And you need to know that in the case of S3 Glacier flexible retrieval and S3 Glacier deep archive, you cannot directly access objects. You have to restore the data when you read the objects. And when you query a table with lowest latency, you can consider S3 Express Run Zone, which was newly introduced last year. Another consideration is storage cost is more expensive compared to other storage class, and the request cost is cheapest in S3 storage class. And S3 Express Run Zone stores data in only one availability zone, so less available. So in general, you need to understand the trade-off between latency, storage cost, request cost, and availability when choosing appropriate storage class. Let me give you an example of use case. Let's say you create a daily report by using Trino, and the data is stored in S3 standard. And you frequently access the data for a short time period. But after a month or two, the data is rarely accessed again. In this case, you can consider moving to another S3 class, for example, S3 Glacier Deep Archive. Now you know how to handle the data with non-access patterns. So next, let's talk about the data with unknown or changing access patterns. In the case of data lake, you may have data with unknown access patterns, and it's difficult to choose appropriate storage class. This is where S3 intelligent tiering comes into play. This class automatically moves objects between tiers based on access patterns, and it allowing you to optimize storage cost. When you put the object into S3 intelligent tiering, it starts in frequent access tier. After 30 consecutive days of no access, S3 intelligent tiering will automatically move the object to the infrequently access tier. And after additional 60 days to the archive instant access tier. So if you have data with unknown access patterns, S3 intelligent tiering can further optimize storage cost. When you're reading or writing data in different storage class using Trino, you need to be aware that the behavior is a little different. You can read objects stored in S3 standard IA, S3 intelligent tiering, and S3 Glacier instant retrieval class without additional parameters. But in the case of reading Glacier objects and writing data to intelligent tiering, you may need to set some parameters. I put some explanation related to the storage class and the parameters on this slide, so you can reference this later. This applies when you use Trino on Amazon Athena and Amazon EMR. So next topic is Amazon S3 Express Run Zone. Using Express Run Zone can help you to mitigate HTTP slowdown error. First, let me introduce the Express Run Zone storage class. This storage class was newly introduced last year. And Express Run Zone is purpose-built to deliver fastest cloud object storage for performance-critical applications that demand consistent single-digit millisecond request latency. One of the key benefits of using S3 Express Run Zone in Trino is its scalability. Unlike a general-purpose bucket, this bucket has no per-prefix TPS limit. And Amazon S3 Express Run Zone supports hundreds of thousands of transactions per second. So by using this storage class in Trino, you can reduce the chance of HTTP slowdown errors. And in Trino, you can use Amazon S3 Express Run Zone with the S3 native implementation. The last topic is managing data lifecycle. This is a solution for unedited data is stored. You can manage your objects in S3 Data Lake by using Amazon S3 lifecycle rules With S3 lifecycle rules, you can define actions that Amazon S3 applies to a group of objects. S3 lifecycle rules are based on the creation date of object and can be filtered to apply to their whole bucket prefix or tagged objects. And there are two types of actions, transition actions and expression actions. Transition actions define when objects transition to another storage class. For example, when you're creating a monthly report using Trino, and once the report is created, the data is really scanned. So in that case, you might choose to transition objects to Amazon S3 Glacier Flexible Retrievable class 1 month after creating them. This diagram shows how to transition between storage classes. Second action is expression actions, and expression actions define when objects expire. Amazon S3 deletes expired objects on your behalf. Let's say you finish analyzing the data, and the data is no longer relevant, needed, and it contains sensitive information. In that case, you can consider expiration actions. So by using the lifecycle, you can manage objects in the S3 data lake and optimize storage costs. So that's all about the best practice I covered today. So let me summarize my talk. In this session, we explored best practice for scaling Trino workloads with Amazon S3, and based on the common challenges you may encounter. So if you're facing any of the bottlenecks discussed, please consider using the techniques I covered today. And if you're struggling with other challenges related to AWS service, such as Amazon S3, Amazon Athena, and Amazon EMR when using Trino, please contact AWS support. And alternatively, if you have any questions during the Trino Fest, feel free to ask me. So thank you for attending my session.
Thank you so much for your presentation, Dai. It's been excellent for rounding out the day. Are there any questions in the audience or online? Excellent, there is. Also, I wanted to mention in terms of contacting Amazon support, you can also find people in the vendor Amazon support on Trino Slack and on the vendor Starburst Slack for Starburst support, which is great to also have them there for your convenience, since you all are already on Trino Slack, I hope.
So, great talk. I have a question regarding Iceberg. Would you suggest storing metadata, specific only the metadata of our Iceberg tables on S3 Express? So could I benefit from the high access?
Actually, I'm not sure we can use Express Function, Amazon Athena, when using Iceberg table.
Yeah, so I use like glue as the catalog, but I set the location of the metadata to a bucket that's S3.
I think it can be used, but let me check later. Yeah.
Okay, right. And another question regarding intelligent tiering. If I have a lot of files, I'm ingesting a lot of data, running compaction on those data, would intelligent tiering cost me more than just running a lifecycle rule on that data folder? Because essentially where I'm making S3 monitor a lot of files. Mm-hmm. So what would be a better approach?
Okay. Actually, in the case of Iceberg table,
I think like the monitoring of like writing files and then compacting them and actually writing the same content but in bigger files just creates a lot of files that need to be monitored. It can, a day's data can essentially be thousands of files. If we sum it into half a year of data, that can be a lot of monitoring. So would I pay more using intelligent tiering than running lifecycle rules on that same folder? Would love to get your input.
I think this is one of those typical examples where it's like your mileage may vary and you have to try and find out yourself, unfortunately.
It's okay, we can talk about it later.
Okay.
It's
Thank
one of
you.
those complex aspects, right? Like,
Yeah.
and also like in Iceberg, obviously the metadata files and the Parquet files are in the same directory structure, so separating them out in different store tiers is probably complicated, if not at all, if even possible, right?
We should follow up there. It's maybe even more of an implementation of intelligent tiering and S3.
Excellent. Well, it's great to have everyone here, including also Dai. Thank you again for your presentation. This rounds out our Trino Fest for 2024. How awesome is that?